In this final video about quadratic functions and their graphs, we're going to look at sketching a quadratic function, but if it's presented in a different format. As a mathematician, we have interest in the following points for this given quadratic. So here's our given quadratic here. It's a parabola, it's a happy parabola, so we would have expect the coefficient of x squared to be positive. The points we are really interested in though, I'll just highlight just now. The ones that are kind of the most important are this turning point, these 2 points here where it crosses the x-axis, and this point here where it crosses the y-axis. If we can find these points, we will be able to plot our parabola. Okay, let's imagine we've been asked to sketch the graph of this quadratic function here. Y equals x plus 4, x plus 2. So this is in a form that we have not seen before. We've got a 5-step process of what we have to do. Step 1 is we need to state the nature of the turning point. What that means is it a maximum turning point or is it a minimum turning point? To find that out, you need to multiply out your bracket and collect like terms. So if we did this, x squared plus 2x plus 4x plus 8. So but the important thing there is it would be x squared. It wouldn't be minus 2x squared, it wouldn't be minus 3x squared. It would be x squared. And because it's x squared, that means that it would be a happy parabola. And a happy parabola would have a minimum turning point. Step 2 is we need to find the y-intercept. The y-intercept occurs when x equals 0. What I mean by that is the y-intercept is a point that's going to be on this line here, and the x-coordinates of all those points would be 0. So we're going to substitute 0 into our equation. It's going to be y equals 0 plus 4, 0 plus 2. So y equals 4 times 2, so y equals 8. So my parabola is going to cross the y-axis at 0, 8. The next point of interest is where my parabola crosses the x-axis. Where it crosses the x-axis, it's called the roots. So the roots occur when y equals 0. So this time we're going to equate y to 0. And we're going to solve this equation like we've done before in previous videos. We're going to split it and solve. And x plus 2 equals 0. So x equals minus 2. So my coordinates are minus 4, 0 and minus 2, 0. So far I've got 3 important coordinates. I have got 0, 8, minus 4, 0 and minus 2, 0. The last thing that I'm interested in is the turning point. If we recall, the turning point is the point in the parabola where it is exactly symmetrical. It's exactly symmetrical about the turning point. So if I've got my parabola here, for example, and let's imagine this was minus 4 and this was minus 2, it would be exactly symmetrical halfway between those 2 points. Here it would be hopefully quite straightforward to see, but in general what you'll need to do is you need to add together the 2 x coordinates and then divide it by 2. So your axis of symmetry, what you'll be doing is you'll be doing minus 4 plus minus 2, so that's minus 6 divided by 2, which is minus 3. So the axis of symmetry is x equals minus 3. So I know that this coordinate here is going to be minus 3 something. And to find it out, I'm going to substitute x equals minus 3 into my equation. Okay, so my equation is y equals x plus 4, x plus 2. So I'm going to substitute x equals minus 3 in. It's going to be minus 3 plus 4, minus 3 plus 2. So that will be minus 3 plus 4 is 1. Minus 3 plus 2 is minus 1. So my y coordinate is going to be negative 1, which means that my turning point, my minimum turning point, it's going to be minus 3, minus 1. So I now have all my important points. I've got my roots up here. I've got my minimum turning point, and the previous slide I found out where it crossed the y-axis. So what I can do now is I can simply sketch this. Again, this does not need to be a piece of art. Okay, so here's my x-axis, here's my y-axis. My graph is going to look something roughly like this. All you need to do now is just to identify the points. So this is 0, 8, minus 2, minus 4, and this turning point is minus 3, minus 1. You do need to label all of these points. Okay, so step 1, you state the nature. Is it a maximum or a minimum turning point? Step 2, you identify where your parabola crosses the y-axis. Step 3, you identify your two roots. Step 4, you find the equation of symmetry, the axis of symmetry, and you substitute that into your original equation to find out the y coordinate, and that would give you your turning point. And then you just do a sketch as shown. We'll do one more example. Okay, here we've been asked to sketch y equals negative x plus 1, x plus 5. I will go through this a little bit faster. Step 1, we need to determine if it's a happy or a sad parabola. We need to determine if it's going to have a maximum turning point or a minimum turning point. So step 1, what we need to do is we would need to multiply out our bracket and collect like terms. So we would have x squared plus 5x plus x plus 1. But we have got a negative in front of our bracket. A negative means it's a sad parabola. So a sad parabola means that it's going to be frowning. And if it's frowning, it's going to have a maximum turning point. Step 2, we need to find the y intercept. The y intercept occurs when x is equal to 0. So we're going to set x equal to 0 in our equation. So it's going to be negative bracket 0 plus 1, 0 plus 5, negative 1 times 5. 1 times 5 is 5, but we've got this negative in front, so it's going to be negative 5. So my first coordinate is 0, negative 5. Okay, that's my first point of importance. Step 3, I want to find my roots. I want to find the points where my parabola crosses the y-axis. Where it crosses the x-axis. It crosses the x-axis when y equals 0. So what we're going to do is we're going to set our equation, equal to 0. So we can split them up. X plus 1 equals 0, so x equals negative 1, or x plus 5 equals 0, x equals negative 5. So my two roots are going to be minus 1, 0 and minus 5, 0. So far I've got 3 of my 4 important points. I've got my root, minus 1, 0, I've got a root at minus 5, 0, and it goes across the y-axis. The y-intercept is at 0, minus 5. What we need to do now is we need to find the axis of symmetry. So the axis of symmetry the axis of symmetry, we need to add together our two roots. So our two roots are -1 plus -5 plus minus is take away. That's going to be -6 over 2. So x is going to equal -3 again. Okay, that's just a coincidence that it's the same axis of symmetry. So I know that my maximum turning point, the x coordinate, is going to be -3. To find out the y coordinate, I'm going to substitute x equals -3 into my equation. That's step 5. So y equals negative x plus 1 x plus 5. So we're going to substitute -3 in. -3 plus 1 -3 plus 5. Y equals -2 times 2. Y equals -4, which means that y is going to equal 4. So my maximum turning point, so maximum because it's going to be a sad parabola, is going to occur at -3, 4. What we're going to do now is we're just going to use all those points to plot or to sketch our parabola. Okay, so here's our x-axis, here's our y-axis. And so, it crosses at 0, -5. It has roots at -1 and -5. And the turning point is at -3, 4. You then just need to add in all your points. Okay, so the quality of this parabola isn't great. It is really difficult to draw on a tablet, but I hope you can appreciate what I've been trying to show you here. So essentially, when you're sketching a quadratic and it's given in the form of 2 brackets, you need to find these 4 points: the y-intercept, the roots, and the turning point. Thank you very much.